Welcome to this video. I'm Physics and today we are going to be going on to current voltage graphs of different conductors. So an ohmic conductor is a conductor which follows Ohm's law. So the current is directly proportional to voltage and inversely proportional to resistance. This will therefore produce a graph which has a steady gradient going through the origin where the current and voltage are the axes. This can be seen through the graphs on the right of the screen. So a semiconductor diode. In a semiconductor diode, there is a forward and reverse bias. For the forward bias, there is a threshold voltage, so it will only allow current to get through if it is past the threshold voltage. Due to this, a semiconductor diode is non-ohmic conductor. So now a filament lamp. When the current increases across the filament lamp, the metal inside will heat up, resulting in a higher resistance. At low current, it doesn't heat up too much, so the filament lamp will be an ohmic conductor as it follows Ohm's law. Due to the higher resistance at a higher current, there will be a curve present in the graph, making it no longer an ohmic conductor. A negative temperature coefficient thermistor. At low current, the temperature of the thermistor will stay constant, so will act as an ohmic conductor by following Ohm's law, just like the filament lamp. However, at higher currents, the temperature will increase, but this time, the atoms will release electrons, or in other words, the electrons will go from the valence band to the conduction band, due to having enough energy to make the jump, making more potential charge carriers, so the resistance will decrease. This is the opposite of the filament lamp, as the graph will curve in the opposite direction, so it will not be an ohmic conductor at high currents. So now we are going to be going on to one of two example exam style questions. So the first one is, the student wrote the following conclusion. The graph shows that in general the LED is a non-ohmic conductor. However, for potential differences greater than plus 2 ohms, Ohm's law is obeyed since the graph is linear in this region. Criticize the student's conclusion. So first you would say, the IV graph for an ohmic conductor is a straight line passing through the origin, as the current and voltage are directly proportional. But this graph doesn't show that, so the LED doesn't obey Ohm's law. So now we are going on to the second example exam style question, where it states, explain in terms of particle behavior why the resistance of the thermistor decreases as temperature increases. When the temperature increases, there will be more energy transferred to the lattice ions. This leads to more potential charge carriers being released. Due to I equals NAVE, where N increases, I increases as well. N is the number of charge carriers and I is the current. So if V is constant and I increases, then R will decrease due to V over I equals R. And there you have it. So thank you for watching this video. I hope you have learned something from this video, and it will be really appreciated if you could share this video and subscribe. Have a fantastic day.